Okay, so we're live. Let me share my screen. So hi everybody, welcome to a technical meeting. So today we're going to discuss a couple of different subjects. First of all, some documentation improvements and how to approach that, as well as some build improvements. Brian's going to share with us some investigation that he's done on some alternate build systems or build frameworks. So let's first start with the documentation improvements. And so I know there is some already ongoing efforts to revise things. And in the past, I know Ayaka, you've done some investigation on Wiki versus other tools. So just a general gist is that Wiki is useful for collaborating on fairly dynamic content, but it's not all that great into composing the content into a book-like format, or which we would probably need for guides. And also, it's not terribly, at least the Confluence Wiki is not terribly great at versioning. I mean, we can create, we've been presently using the wiki spaces to freeze content in time, but because we don't have any, it's partly the tool and partly the process that we've been following. But I think there is multiple different motivators for us to start looking for some alternate approach. And I know, Ayaka, you've done some work on this, right? So there's do you want to talk more about that, or?
So I haven't done any research recently, I guess, but a while back I had talked with several other people who were also part of documentation for various other open source projects, and one of the ones that came up was using REST, which is restricted text, that was originally developed for Python, I think it was. And they were using that and a framework called Sphinx. And what that kind of gives you is this pre-formatted framework for creating these exactly book-like things that can be kind of just built like Java docs. You can just build HTML, PDFs, those kind of things. If you throw it onto GitHub, it kind of gets rendered pretty automatically because I think GitHub supports REST. The formatting itself isn't as convoluted as several other wiki formatting like languages that I've seen before. So I think that would be a pretty nice thing to at least do the relatively static and slowly evolving content in, but maybe not for things like tutorials that people might want to change very often, because we're ultimately having a bunch of different text files basically. And the pros of having that would be that we can actually just put it into like Git or something, or have like another Gerrit for peer reviewing and version control, not version control, but like we can do whatever we do with code to make it sane on the body of text. So that'll be kind of a bit easier. We can even apply like the module owners type of thing and have different owners for the different sections of docs if we want. And that might actually, well, it's going to take some time to move whatever we have in the wiki to that format, and that's kind of unavoidable, but sure. I think on the long run it will be much more saner. Because another thing that you can do once you have this body of REST docs is kind of, as part of the ONOS system, you might be able to say like make docs as part of like the build, and pull in the right version of the documentation for that right version of ONOS, so you can also start getting rid of these like version inconsistencies. And
right, exactly. That's one of the issues that we've been running into. Of course, it's predicated also on having a reasonable process for updating things, but at least we can version lock certain content, even if it doesn't arrive at the same time. We can still version lock them together, right? So this commit hash is for this version of ONOS.
And have like different branches maybe for different versions, or I mean, like the initial cleanup's going to be painful. Like there's
sure. So now you've been so while on that subject, so I know you've been working with David a little bit, and also working with Emerson and with Elena on maybe getting started on some of this stuff. Is that the case, or? Or do we have any timeline or any planned approach for how this is going to happen?
I feel like this is pretty involved in large in scope, so I was kind of counting on the spring cleaning.
Spring cleaning, okay.
To kind of get this started. Elena and Emerson are more working towards trying to get the ONOS for beginners type of
I see, okay, so it's a little bit different, okay.
So that it's more accessible to people who might not be very familiar with things like Linux or command line and those kinds of things, and being able to kind of get them over that initial hump to get started on ONOS faster.
And just for everybody's benefit, is this on in a wiki as part of the wiki content, or is that completely something separate, sort of separate publication?
Right now, yeah, we just have like a separate Google Doc for like the minutes for those meetings for any kind of doc-related work.
No, but what I mean is the beginners, let's say for the ONOS for beginners type of the material for that, is that being collected on is it being authored in wiki, or is it being authored in somewhere else? Like
actually, this morning we created a staging page for that, so Elena is actually
so it's going to be on wiki. Okay.
Just to get more eyes on it, and since it seemed pretty polished at this point, so beforehand we were working through Word documentation.
Okay, so that's part of sort of ongoing wiki reorganization, right? And that's you have the suggested reorg wiki document here, right? If I were to follow that link here. So that this is just for overall
so that's
restructuring of wiki content in different pages, right?
That's like the super high level, looking at the very top entries that we have for the wiki. And I guess more of my focus with the long-term maintenance was towards the guides.
Towards the guides, which is which is more of these things, right? The
and the other, the outline that I had for the other file. So there was that file that Luca had started, and then there was the other, a more detailed outline for each of the guides. And based on the conversation that we had through that thread, it seemed like we wanted a new guide or refactor the current set of guides or the tutorials and sort of just logically split out them more cleanly based on topic.
I see. So in terms of, so there's some foundational work that we have to do in order to enable the community to do all of this work. So hence the spring cleaning, right? And now at least in some of the wiki reorganization. So it seems like in the meantime, then at least if there is any documentation effort that's happening, it should be still redirected towards just making sure that the wiki is accurate and reasonably organized, right? That's something that can be happening as it's been happening, right? But maybe a little bit better than it's been happening.
So like one of the things that a friend of mine suggested to me was to have this, like this outline, just to be able to do like a general like scan through to say, okay, these pages are outdated. Okay, let's add these pages. Let's reorganize these sections. And it turned out that doing that does give you like a very good high-level view of what needs to be done. So after that's done, it's better to kind of move it to maybe a ticketing system or maybe even a page in the wiki saying, okay, this person's working on solving this problem, this person's working on adding this page or updating this page.
But at least there's then a framework for other people to collaborate on, right? Because right now it's without some of the groundwork, it's difficult to do that.
Yeah, so like if we first can get like a group of people that are willing or maybe assigned, these reorganization tasks, and just kind of publicly change them on a page in a wiki like the module owners, that might be a good place to start.
Okay. Just a quick question for process. Is there any questions on
well, there's a question tabs open. This is familiar.
Okay. So the groundwork's going to happen. In the meantime, you just need to hammer on the wiki reorg. On a wiki reorganization, because that can be done on the fly, and then supplying the correct content for the wiki. And for the user guides, those will have to basically come from the spring cleaning. One thing I also noticed today, moving now to the next section. I noticed that our Java docs, we have our Java docs organized in groups. It's not a flat list of packages. It's sort of these groups of platform, utilities, drivers, and so forth. And it definitely takes some care to make sure that those sections remain maintained in their integrity. Because for example, somebody adds an application. Guess where that lands? It doesn't go to an application. It goes to the main APIs. So that definitely requires continual monitoring, which is fine. But so I've cleaned that up. But as part of trying to clean it up, I've noticed that our Java docs are becoming very, very large to the point where just even the initial list of packages is just ginormous. We have well over 100. I think we probably have. Probably almost 200 packages. And so it seems like we might want to start considering at least breaking it up into sort of either base platform and some utilities, potentially coupled together with a network core API, and that's it. And then maybe separate the applications and then also from at least into their own section, and potentially maybe even just not bother with having page of all applications together, maybe just having applications sort of fend for themselves. If they have an API, provide their own Java docs. And then similarly for the protocols, providers, and drivers. Because those are really not used, the protocols may be an exception to this. Protocols may require sort of use in context of a reference for the API for the protocol libraries. But the providers and drivers, really those are fundamentally just implementations. So I'm not sure that they will require their own Java doc sections. And one thing, a nice thing about them still producing Java docs is because the code ends up being documented. So I still would like to at least generate the Java doc bundles for them, even though it's an internal only Java doc. Internal meaning it's really for the people who are maintaining the code rather than for people using the code. Because currently we generate internal docs and external docs. In the external docs have just APIs and utilities and basically things that an application developer will be using directly, but not necessarily somebody working on ONOS. Somebody working on ONOS would be using the internal docs, and they contain everything, which includes implementations like the managers and implementations of the stores and some of the internal mechanisms. So I think probably part of the spring cleaning should be to break this apart so that it becomes a little more digestible. Plus, also, it doesn't take such a long time to build. Because currently, the internal docs take about 1.5 minutes to build, and the external ones take about 1 minute. At least that's just a quick recap of what's happening in documentation space and some of the improvements that we plan to be making in that area. Hopefully, we can get a lot of help from community. So, on the other subject, on the other topic, which is the improvements.
So I've been trying to talk, but there's never any break in that I have a chance to. That's all right. It's always like this. Part of it is due to the lag due to remote conferencing. Anyway, I had a bunch of comments on this, and I just wrote a few of them in the document, so check it out.
Sure.
Yeah.
Okay. So where do we delete the paragraph? Yeah. Okay, so.
Yeah, I think this is all good. Just take what I said into account as my advice.
I see. Okay. So basically,
I mean, the main thing really isn't our process, and it's not the tool. I think moving to REST and Git will only make things worse. It doesn't address the root problem. The root problem involves paying several people who have deep knowledge of the ONOS system and are very good writers to write the documentation.
Sure. Okay.
That's the core issue, right? The core issue is that we haven't done it, and that the sort of qualifications for somebody who could do a good job are skills that not many people have, and very few people, the people who do have it, aren't going to want to write the documentation, and we're probably not going to want to pay them for it. So that's kind of why it's sort of a doomed process, and that just tweaking the process is really not going to help.
So I mean, I agree with your assessment. I guess I disagree with your prognosis. I don't think we're doomed, but I think it's definitely. I mean, you definitely have a point in this, that this requires somebody good at writing and somebody with a reasonable level of knowledge of the system. But this is where we're planning to start leaning heavily on a community. But before we can do that, we need to provide some sort of a substrate or basis for organizations, for them to, and sort of environment conducive to collaborative development.
Yeah, I agree completely, and I would say that GitHub is probably the wrong environment. It's like I've written so many papers in version control systems, and it's just utterly painful. And so once Brian and I switched over to a Google Docs-based workflow, it was like a revelation. It's like I'd been living in a cave my whole life, So I think we should, if at all possible, have a sort of dynamic, user-friendly environment, and not something that's horribly painful like checking crap into version control.
But keep in mind that, like, I was just giving that as an example of a tool, for example.
Yeah. So
I wasn't saying we're doing this and this. It wasn't a. So we have room to experiment or think more about it before spring cleaning.
Yeah, I think collaboration, something that supports a collaborative workflow, is a really good idea, and something that requires you. I mean, having used version control systems for writing papers, I can just say it's really, really painful, and I wouldn't wish that on anyone.
I agree with Bob, and this is Elena listening in a conversation. I agree on both points that Bob made, that writing good documentation does take time, but the payoff, I think, is good. And for me to partner with people like Ayaka and other who are willing to give a little bit of a coaching so we can get people kind of to understand the subject matter that you're experts in and provide better quality documentation, and moving it to more friendly environment. So Google Docs will do it. Or is it an option?
I'm not necessarily recommending Google Docs, but I just want to say that it's, having used it before, it's much more conducive to collaboration when you have more than one person writing on something. If you just have a single person working on something, typically, a regular kind of document preparation system, something like, doesn't really matter what it is, something like Rust or something like, Word or any of the tech environments or whatever you're comfortable with. It only becomes an issue when you have more than one person working on it. I think we want to enable that, and so having something that supports a really kind of easy-to-use collaborative workflow would be really nice.
Okay, noted.
Yeah, it's more the versioning stuff.
The versioning and the ownership, I think, is also two other issues that we kind of need to strike a balance about.
One nice thing about Google Docs is it retains every version of the document. So that's a good feature. I agree that versioning is really good. I mean, things like traditional PC word processors do versioning as well, but usually they don't have good collaboration. Although there's kind of, Office 365 allows you to do collaboration online with Microsoft Word documents, and Word's not a great tool for writing books, but the collaboration is nice.
Okay, yeah, we'll have to wait some of those things, right? Go ahead, Lucas, sorry.
No, just saying that we need to find the tool, but this is secondary, right? Before we need to find the right process that we want to, and then we can find the tool. I guess here the discussion is more initially on the process we want to have, and then, of course, it must be nice and comfortable for everyone to insert, review everything. We want the revision, and we know that, but
we need to start on it, though.
Yeah, we need to start it. We're going to have to make a decision, right? So, and there will probably have to be, there's pros and downsides to everything, right? So we'll have to figure out what platform works best for us and just go with it. And main thing is that we have substrate on which other collaborators can start working, in my view. And the versioning, the implicit versioning of Google Docs is perfectly fine, but I think we need to have almost explicit versioning in a sense, something that we can point to a specific version in time and then sort of have a fixed reference to that.
Well, yeah, and needs to be compatible at least at the beginning with our authentication and authorization system, which is not trivial for Google.
I think most versioning systems allow explicit versions and also time-based versions.
Yeah.
Google Docs does also. But I'm not really recommending Google Docs. I'm just sort of pointing out that it's much better than that sort of switching from a more static system to more dynamic system sort of dramatically improved my productivity and happiness.
Mm-hmm. Yeah, that's that. But I think if we have the good content, then the tool will evolve. Just having what we want to share, I think that's the preference.
Yep.
Does any one of the collaborators that help with documentation, probably as Elena, I guess, know anything about tools that we usually use in these cases? I mean, are there famous tools, you know, as Word is, Microsoft Word is famous tool as word processor? Are there good tools?
People seem to like Google Docs a lot, and people also do seem to like Sphinx a lot as well. But again, that kind of gets to be a hurdle because each system has its own quirks and like maybe even a formatting language. So it's kind of it gets pretty hairy if we start talking about it now, I think.
Yeah, for sure.
Yeah, I think so. I think so too. And I guess one comment on Rust is it's not terrible. The only thing that I think will make it usable is having a dynamic version control system.
Noted.
I like version control systems.
Yeah, but because you're a developer, of course you like it.
It's going to depend.
You live with it.
I like them too.
Of course, the developers. All this room like it, surprisingly.
It's going to depend on who's like our main body of like contributors too, because if they aren't developers or like people who.
I mean, you can make them easy, right? Like there are tools for like you don't have to like use Git. Right? Like you can use GUIs for Git and allow you to switch branches. That's what's going to end up happening, right? I assume you're going to have the versions, the documentation for a version under a particular branch.
Yeah, you can be leaving just 99% of our deployments. How much time I spend just to explain to people what is a branch. I know this is a problem, but but seriously, I know this is another problem, and it's a problem of other people, whatever. I'm just saying it's another barrier at the entrance if we are looking for people that want to collaborate.
So we need to consider it, but we'll have to have versioning, whether it's an explicit versioning system like a Git or whether it's something that's sort of baked into the online tools, like Overleaf is its own, right? I mean, it's actually Git underneath.
Oh yeah,
That's an example. That's an example that actually you don't have to expose the versioning system.
No, of course. If we find a web interface, like a form of a website that doesn't mention things like a branch or things like that, but just you go and you click edit and it opens a page, that would be great.
Yeah, I agree. I think Overleaf is a good example. I'm not recommending that we necessarily write our documentation in tech, but it's certainly so much easier to write stuff in an online environment like Overleaf, even if it's tech inside, than it is to have tech files checked into your version control system of choice. The reason is that when you're doing sort of fine-grained edits and collaboration on the same piece of text, version control systems really break down, and it's kind of, they create tons of conflict. And you've probably experienced the same thing even in code when people are working on the same module and making lots of changes at the same time. It creates a lot of messy merges, and merges of code are bad enough, but merges of text are total, and text formatting systems are an even bigger nightmare, I think.
Yep. Noted. So unless somebody has some other sort of suggestions or sort of observations, I think we should probably move to the build improvements portion of the program. I think for that I'm going to hand it over to Brian. He's done some investigative work on how to improve our build times and simplify the general model of working with ONOS.
Cool. You want to switch to the slides?
So I guess just to provide some context, currently, as most people know, we use Maven for doing all our builds. Maven's a pretty comprehensive piece of software that does a lot of stuff. It's been around for a long time. There's lots of plugins, and it all sort of works fairly well for us now. The one downside to our existing setup is that the initial builds are slow and incremental builds are slow. There are some ways that we could...
Everything's slow.
Sure. There are some ways that we could potentially tweak this, but if we're going to spend time and effort on this, there are some other options that we should be considering. One of them is Gradle. I have a slide on that at the end, and we can talk a little bit more about that later. One that I've discovered that not too many people seem to be familiar with is called Buck. So we can go to the first slide. Just to provide a brief overview, Buck is a build tool rather than a sort of a build system. It was open sourced by Facebook a few years ago. I think it was either based in terms of code or in terms of theory on Google's build tool, which is open sourced. Their internal one's called Blaze. Their open source one is called Bazel. And sort of as a side note for, does Buck work and does it scale? I think all of Facebook Android app code is in the same repo, including Instagram, and they use Buck to build it, and they have very little tolerance for slow builds. Sort of the overview is, at a high level, Buck has a few concepts. There's build rules, build targets, these are just the names for those rules, and then build files. So these describe the rules. The rules form a DAG, so you explicitly name all of your dependencies. It has to be acyclic in order for this to work, and then it builds a rule's dependencies before a rule itself is executed. It's optimized for building multiple deliverables in a single repo, so we can have our one ONOS repo with apps, with core, with southbounds, etc., and have a common target for all of them or individual targets for each of them. Facebook claims that maintaining dependencies across the same repo is a lot easier than having to maintain dependencies across multiple repos, specifically because you get into versioning hell when you have moving targets, multiple moving targets. So in a single repo, you can update things with an atomic commit. The next sort of piece of criteria about Buck is it's fast. Garrett, the code review tool that we use, is open source. They use Buck for their builds. Their Maven build without building Javadoc or tests was almost 7 minutes. Their clean build with Buck is about 2. You still have to do code compilation and other stuff, which does take some time. They have a lot of source files like we do. But the interesting thing here is the incremental build time. So they're no op rebuild, basically make no changes and just run the build again. With Maven takes almost 5 minutes. With Buck takes 2 seconds. If you run Buck daemon in the background, which watches the directories and automatically detects changes, their incremental no-op build time is less than a second. I also looked at another guy who did some performance benchmarks on a fairly large project. I suspect this was a proprietary project in his company. They were using Gradle, and he was seeing initial build times with Gradle for his project at like 3.5 minutes. Incremental build times with Gradle, no-op rebuilds at about 20 seconds. With Buck, he saw that he was able to get a lot more parallelism out of this because the dependencies were explicitly named, and Buck was able to take advantage of that. By default, it runs 1.25 build threads per core. He saw his build was under a minute, initial clean build, and a rebuild of 3 seconds, or almost 4 seconds. So if you're comparing Buck to Maven, it's way faster, and if you compare Buck to Gradle, which we'll get to in a little bit, it's still a bit faster. And one of the questions is why, or how is it so fast? If we go to the next slide, one of the biggest sort of things about Buck is that it's got a cache. It's both got a local cache, so every time you do a build, it takes a hash of the files, the input files. It figures out whether it's done this before, and then if it has, it takes the output artifact of the build. So for a local developer, you see a massive increase in build times, especially if you're switching between branches. But it's also got the functionality of a remote cache, so you can run a team server, and then as a team, you can share build artifacts. So if I built a new branch, some new code in a new branch, and was plugged into the remote server, then anyone else in the team who wanted to build that same branch would be able to download the artifacts. So if your network's fast, this is great. If you want to work offline, you use local cache, and that also works really well. Facebook did a study. They engineered all their developer work environments and found out that 97% of the build work done on their developer workstations before they switched to Buck was 97%, and only 3% of the time that their developers were spending and the work that was being done by their build systems was unique and useful. So what this shows is that 90% of the time you don't need to be redoing stuff, and with Maven, you have to run through all of the plugins for all of your modules, for all of your subprojects if you build from the top, which is extremely expensive.
Yeah, that's really painful. Using the hashes is a good idea. It's sort of like what Ccache does.
Yeah. I think Gradle uses timestamps. I mean, Ant and Maven and Make certainly use timestamps. One of the problems with timestamps is that when you switch branches and stuff, it detects the files as new and changed in some cases. There's also weird systems. In bigger projects, you can get into weird race conditions where the build systems get confused. But if you use a hash, you know what you're getting, and it's easier to share artifacts as well.
It's not really a problem with Make, because with Make and I guess Git, Make, and Ccache, it's not a problem, right? Because every time you check it out, Ccache will detect it's the same hash, or it'll detect it's a different hash, right? And
yep.
and everything is versioned anyway, so Make will trigger Ccache, but then Ccache will do the right thing. So it actually works pretty fast with C, but the overall idea is a good one.
Cool. So yeah, we can go to the next slide. The other thing that Buck does well is it's Java aware. So Buck knows sort of what's going on with your code. If your library or API doesn't change, it doesn't rebuild the downstream dependencies on that API. So it knows the difference between changing the name of a class or changing the name of a method or a method signature from changing the value or the implementation of the methods. And it'll detect when those changes have been made and rebuild just the library if it's implementation differences, and it'll rebuild the downstream or depending upon downstream in the DAG dependencies if there's a change.
Yeah, this is really good. This is exactly what we were talking about. I was like, you really only need to compile when the API changes, but it's clear that Maven is doing tons of recompilation even when that's not the case, and our ONOS build system is even worse.
So one other thing is that Buck doesn't explicitly manage dependencies. Buck just manages build rules. And so in order to get dependencies from the internet and other things, you have to explicitly name them all as effectively targets that can be then depended on in your other build rules. There are some existing plugins that will scan through Maven projects, search out for all the dependencies, and then generate things like you see on the left. But here is sort of a classic Buck rule. You have sort of a rule descriptor here. This is an extension of the Buck main API, which defines a Maven jar, gives it a name, so that name is how you depend on it in other modules. And then it gives the ID is the group ID, the artifact ID, and the version. You provide a SHA-1 hash so that it knows when it fetches the artifact from the remote site that it got the right one. And then this is an example from Garrett. But for them, they also are able to, in their documentation, generate a list of all the licenses of all their third-party dependencies. So they put that annotation in here as well. So this isn't Buck doing dependency management. This is developers doing dependency management with some help from some Buck extensions. So we can do that. That would be sort of a big change.
Yeah, that actually is a big change. And if you look at make, the main reason why people moved around away from make is that they found that sort of manual dependency management was kind of painful in large projects. Although, obviously even the Linux kernel still uses make, so you can scale it. It's just kind of painful. And there are a lot of systems like, I don't know, like SCONs and all sorts of IDEs that automatically generate dependencies. And so my question for you is, like, what about people who don't want to write dependency rules manually? Will it automatically generate the dependencies?
I don't believe so. You'd have to define the dependency that you want in the lib file, and then from there you could depend on it.
This is your number 2 major drawback, which is no native dependency management. So that's kind of painful.
Yeah. So here's sort of a list of the drawbacks. One is that there's no native OSGI support at the moment. Their focus has mostly been on Android, the Android side of Java. However, building plugins, like for example, building a wrapper to build a war file is a couple of lines of build script. It's Python, so it's fairly easy to write. But here's def war. You provide a name, some libs, etc., and then basically it's a wrapper on an executable called pack4 that will pack this thing up. We could use bind lib to do this for OSGI. We could do the same thing for check style, unit tests. We could even take things like STC, define those tests in Python, and then include those in the build automatically. The other drawback, which not too many people in this room care about, is that you can't build on Windows natively. So
You build on Cygwin?
you can build on Cygwin, you can build on OS X, you can build on Linux. I think it's mostly because they use Symlinks and some other Linux lines.
Did you say you can build on Cygwin or you can't?
I believe you can.
So that sounds pretty reasonable. I mean, I think that's a decent approach, especially for ONOS, which probably is going to run in a Cygwin-like environment on Windows anyway, if people are going to use it.
So I guess from the Buck side, if we wanted to go for pure speed, I think it's probably our best bet. However, there are some significant drawbacks, as we mentioned here. It's also going to require a fair bit of work to retool the way that we do our build process. We need to generate a significant number of wrappers or extensions to Buck to do a lot of the things that we currently do. Again, these things aren't that hard to write, but it is work to be done, and we would need to be moving to a world where we either find another dependency management tool or manage them ourselves. Another option, and this is the Gradle slide, would be to go with Gradle. Gradle has a slightly different mentality from Maven. There's lots of documentation on Gradle's website that explains it to you. It's a fairly mature build system. It does dependency management. It's got a ton of users, a ton of plugins. There's auto migration. I don't think we would get the same degree of performance. And part of this is because when you do builds in Gradle, it still has to scan all of the build files and then decide which of them need to be redone. So there are a few drawbacks to Gradle. I think Gradle would be much better than our existing Maven situation, but it wouldn't necessarily solve all of those problems. I think my gut feeling is that if we're going to spend the time and effort, it'd definitely be worth a deeper investigation into Buck. And then if we decide that there are too many drawbacks, or the drawbacks that we encounter are significant, then Gradle would be a good backup plan. But either way, I think we should move away from Maven after ONS.
So, Ryan, one of the things that Maven does a really good job at for us is this notion of fetching and maintaining repositories. Mm-hmm. We used Gradle at Dell, and I know we used Artifactory, so clearly it did something that I didn't understand how it worked. How does Buck deal with that? Same sort of deal. It'll go out and find, the JUnit jars for you and load them down.
So Buck itself doesn't care. You can tell Buck that I have this remote file somewhere, and it'll fetch it, and it'll verify that the SHA that you expected it matches, and it'll store it. It'll cache it for you.
So you have
getting
to
getting the Maven repo. Well, so when you say find it, if you know what the group ID is, so what I showed you before, if we go back a couple slides, is there is a wrapper that the Garrett guy used to be a Maven project, and they switched forward to 3 slides. Oh, this one, yeah, you're right. This one. This one, yeah. So the Garrett used to be a Maven project. They switched to Buck because their build times were getting sort of unbearable for them. They built some wrappers. Here they call it Maven jar. And so what this wrapper does is actually backed by some Python code that uses the Buck remote file fetch command. So this is, they've got 20 lines of code that basically interpret this, and then they know how to basically convert the group ID, artifact ID, and version number into a well-known URL to fetch the artifact. So there's no manual going and getting the dependencies from the internet and copying URLs anywhere. The way that you define your dependencies looks a whole lot like it does in a POM file. But there's no automatic, this isn't automatic, and the behavior can be customized. But once you build the extensions that do what you want, and there's also an extension that they built, Maven package, that packages up the artifacts, and then you can install them into your local or remote cache if you want. So there's a number of people that have been building extensions and making them available in other open source projects that will do a lot of Maven-like things. Unfortunately, there's other ones that I couldn't find. War is one that I found. There's not one that I found for OSGI, but again, the process of doing this is you generate you do your Java compile, test if you need, and then you basically would just call BND or bind to generate the OSGI compatible jar that includes the manifest and the XML files for the system components.
So I guess this means then for things like Sonar and Checkstyle and JUnit, we'd have to write those plugins?
So we would have to, for each of the things that we want to use that aren't built into the build tool, we'd have to write a wrapper for them. And then it becomes fairly straightforward to just inject those into the existing build rules. So my suspicion is what we'd be using is we wouldn't be using the native Buck build rules. We'd be using ONOS rules that would then use definitions of those. And that's why I say that getting this up and running would take some work, because it would a lot of the build tools that we currently have, like the Maven bundle plugin or the OSGI bundle plugin, I forget what it's called, basically uses BNDLib in order to bundle up the jar. And they call a binary to do it. So we would just be calling, we'd have to write the wrapper to call the binary. So we wouldn't have to necessarily do the work of the heavy lifting of Checkstyle or the heavy lifting of this stuff. We just need to call the binary with the right parameters.
Yeah, right arguments. And one last question. When we used Gradle, we had a lot of problems with Eclipse plugins not understanding how we were doing Gradle. And then you'd get all your Java files turned red, and it was just such a pain. But that's actually why I switched to IntelliJ, because its Gradle reader was better.
Yeah.
Did you play around with Buck readers? Plugins, whatever they want to call
them. So there is a Buck. Okay. So two things. One is that you can generate the project files for IntelliJ or Eclipse via a built-in Buck target.
Oh, okay.
So you can generate that stuff to bootstrap yourself. And then there is an IntelliJ Buck plugin that I only spent a few minutes playing around with, but it does let you execute build targets from within the IDE.
Okay.
So that would be part of a longer investigation. I think this was sort of I slapped this presentation together in like the last hour.
Okay.
So it was just to kind of get people thinking about this and really to introduce Buck, because it just talking to people at lunch, it sounded like no one had heard of it before.
Yeah, I hadn't heard of it.
And I think more people had heard of Gradle, so I figured. And there's also Gradle's got. Buck has a lot of documentation now too, and Buck is maturing fairly quickly. Gradle's been around for a bit longer.
Yeah.
But a lot of the same issues that people run into with Maven, they run into with Gradle. And there's other issues that pop up as well. I think that Gradle support probably is better in both Eclipse and IntelliJ than it was, even a couple of years ago.
Mm-hmm. So I think we can expect the same thing for Buck.
Yeah, I think so too. I think a lot of these things that we're talking about, the missing pieces and plugins, it's only a matter of time before more projects switch. And oftentimes with build tools, people either look at build tools when they're starting a new project or when they've hit like a pain point. And that's kind of the point we're at now. And I think there's other projects that will sort of hit these sort of pain points. A big thing about Buck is that it's designed to work well as for an individual and even better as a team. And so when you do have groups of people that are co-located, or you do have a build server, for example, our Jenkins build now take 11 or 12 minutes to do a validation. Most of the time, there's only 1 or 2 modules that have changes in them. But how do you figure out what the relation of this module is to the previous one? If you use a hash-based approach, whether it's Buck or Ccache or whatever, now you can bring the build time, even just using the local cache, you can bring the build time down dramatically for verification builds. And if we do that and potentially get those times under a minute or something, we potentially have more time to do things like spinning up clusters to do system integration verification, which would help protect master. And the other thing we could potentially do is enforce a rebase on force a rebase before merge, because we have had some problems where people just click submit, and if there's 2 conflicting changes, you can get a break. We have that turned off because we've sort of said, okay, let's just try to be careful, and we don't want to wait, the whole afternoon to merge 5 changes thing. But if it was fast, and you could say sanity, Garrett, and integration, Garrett, first push we do integration, and then a rebase we do sanity. I mean, you could potentially validate these things very, very quickly, and there'd be less penalty for doing so. So, yeah. The other thing about bringing the build times down is you just waste less time sitting here and just have to recompile.
Mandatory XKC.
Yeah, compiling.
One quick question here about, so in this example right here, you sort of declared essentially just symbolic names for the Maven jar, right, or for the JSON versus Guava. Now in here we specify the SHA, or the hash code. This is for tracking external dependencies only, right? What about the rolling dependencies, the internal dependencies that we build on, right? So it's clearly not going to be able to do that because those will change. But
So for the dependencies that are part of the project, there's already a named build target. So you already have a build target called ONOS core or ONOS forwarding application or whatever. And if you have a named build target, then Buck tracks the dependency perfectly. What these things are doing is they're just introducing a remote file, specifically a remote file backed by a Maven repo, into the Buck environment so that it can be referred to. So here, I have a jar somewhere on the web, specifically in Maven Central. Here are some parameters that will be useful for you and a SHA to validate that you downloaded it correctly. Oh, by the way, it's called Guava. And now, internally, you can just say live Guava, for example, or live JSON, or JSON. And now that's how you would depend on this Java library from within other modules. And the other modules can depend on other modules. That's not a problem.
Right. Okay.
And here, it says include defs, live Maven defs. That file, live Maven defs, is just the definition file for the Maven jar extension, which wraps. And we can. It's similar to looking to the war.
Sure.
It just is fetching from the internet instead of building a war file.
Yep.
But yeah, in general, it's Python. So these are just Python functions.
So it seems like it would be a good idea to, maybe designate that portion of our source tree like utilities or something like that. Probably utilities because it's fairly high up in the hierarchy, right? And just trying things out there. So we're going to take it for test drive. And I think at lunch you were suggesting that we leave the POM files.
Yeah, so
you want to elaborate on that?
The other thing that I might mention, and then maybe we can get to Bob's comments because there's a bunch of them, is that one advantage of moving to either Gradle or Buck is that we don't have to do so with like a switch. It doesn't have to be a hard date where everybody has to switch over. We can leave the POM infrastructure in place and let people continue to build with Maven for some period of time, and then let them switch to Gradle or Buck as we go by having parallel, what's it called? Parallel build files in the same directories. So we put the Gradle files next to the POMs, or we put the Buck files next to the POMs, and then there is some overhead to maintaining two of these, but they don't change all that frequently. Then one day, when we decide that everyone switched to the new environment and it works and we've got the hiccups out, then we can pull it.
Seems like it would be a good idea to tackle it at the start of GoldenEye, and then by the time the GoldenEye releases, we should be done with the compound. That's what I think.
Sure.
I don't want to drag it out too long because I think there's inherent costs and confusion.
Sure.
Yeah. Do you want to try to address?
Brian?
Yeah.
No, one quick question.
Sure.
So the dependency here, you define it as the build dependencies or as the running dependency?
These are build dependencies.
Okay. Do you take care of the running dependencies?
That's
That's
runtime.
by OSGI, right?
Yeah, runtime dependencies are handled by the features XML files in OSGI.
Okay.
Well, yeah.
Honestly, we're sometimes using the dependencies for shading and stuff like that, right? Which does transcend into runtime. But I think it's enough if you have built-time dependencies, and we can deal with the runtime dependencies in sort of a secondary mechanism.
Okay.
I mean, right now what we do is the runtime dependencies are fetched from the features XML files. We'll pull in all those.
Yeah, like for example, we're using the Karaf assembly plugin to be able to coalesce all of the runtime dependencies so that we can package them all together for basically having a isolated install. Right. Yes. Hey Bob, did you have some questions?
Oh, I think they were. I wrote them mostly on the side, and Brian was going to address them, I think.
Yes, I was looking at the list. Sorry. Yeah. But I figured maybe you want to drive through them, or.
Oh no, I think I don't know. Brian can just come in it. I mean, this looks really good to me. I mean, I think we currently have a really painful sort of compile, edit, test cycle, and so fixing the compile part of that. And making it really fast and making it work sort of in the background as you type in your IDE, or just with a quick command line that takes 2 seconds to complete sounds like a huge step in the right direction. And I would say kind of speed overall, that even if the dependency management is bad and painful, you don't usually do that 20 times in a day, whereas you might want to compile many times a day.
Yep, that's the whole goal here.
So Brian, did you have any responses to the stuff I wrote?
Yeah, no, I mean, sort of agree with the first several things. I'm looking right now at the part about Ray's question is a good one. Yeah, I think we should definitely do a trial run with a small portion of the code base and see, A, how complicated is this going to be, start to build some of the wrappers to get a feel for that, and actually do some of our own speed comparison tests just to validate the results that others are seeing. I think we could also do more of an analysis. There's actually a GitHub project that compared on a couple of different workloads, Ant, Maven, Gradle, Buck, Blaze, SP, PT. There's a number of projects that someone already did some legwork to do. That's in terms of sheer performance.
Nice.
But we could also try to enumerate the pros and cons and how much we weight each of those things. In general, I think that the fastest tool is going to be the most useful to us. And it sounds like if we're going to go through the process of doing this from scratch, there is some time that we have to get it right.
Yeah, I agree. I agree completely that I think the fastest tool is probably going to win, just because you compile so many times, and the other sorts of things are sort of less common, so they don't necessarily have to be as convenient, although it's certainly nice if you can make them as easy and user-friendly as possible. And I think Ray's comment of sort of being able to do things like making sure you can run your code check in the background in your IDE as you type will definitely help people out and sort of not interfere with people who are already using an IDE and force them to take a step backwards.
Yeah, no, I think it'll be, from my standpoint, I was originally thinking we would convert to Gradle, but because Gradle benefits from the experience, right, that was achieved through Make, and others. But seems like Bug is a little bit more modern, which means that it also doesn't necessarily make it better, but what it does, what it does mean is that it has the benefit of learning from the others. And so that's the whole reason why I think we should go with Bug, which means if we're going through the effort of porting things, we should just port it as far as close to the edge as possible.
Yeah, as long as it works and doesn't have any sort of fatal disadvantages, I agree completely.
Yeah. Hence the parallel approach that we will be taking. So, all right. So I think we're past the top of the hour here. So unless there is some other questions, concerns, or suggestions, I think we can call it a day.
I think the performance numbers.
All right. Well, thanks, Ayaka. Thanks, Brian. Thanks, everybody. We'll see you next week.
Great,
Thank you. Bye.